In the winter of 1868, a French astronomer named Pierre Janssen traveled to India to observe a total solar eclipse. He brought with him an instrument called a spectroscope, a device that splits light into its component colors, like a prism spreading white light into a rainbow. But Janssen was not interested in beauty. He was searching for something deeper, for answers written in light itself. When the moon's shadow fell across the sun, and the solar corona blazed into view, Janssen aimed his spectroscope at that ring of fire. The light, when split apart, revealed a pattern, dark lines crossing the spectrum, gaps, absences where certain colors should have been. Each line was a signature, each gap the unique fingerprint of an element absorbing light at a specific wavelength. And there, in the light of the sun, he found something that did not exist on Earth. A signature with no name, an element no laboratory had ever isolated, no chemist had ever studied. They called it helium, after Helios, the Greek god of the sun. It would be nearly 3 decades before anyone found it on Earth. Trapped in uranium ore, a ghost made real. That moment marked something. The stars are not unreachable. They are furnaces, the birthplaces of matter. Everything you are came from there. Look at your hand, the calcium hardening your bones, the iron carrying oxygen through your blood, the carbon forming the backbone of every protein, every strand of DNA, every molecule that makes you possible. None of these elements existed at the beginning. In the first moments after the Big Bang, there was only hydrogen. Simple. 1 proton, 1 electron, and helium, 2 protons, 2 neutrons, 2 electrons, the 2 lightest elements, born in the fire of creation itself. For hundreds of millions of years, the universe was nothing but vast clouds of these gases, drifting in darkness. No stars, no light, just hydrogen and helium, slowly stirring in the void. Then gravity began its patient work. Clouds collapsed, atoms pressed together, temperatures rose, and in the crushing heat and pressure at the centers of these collapsing clouds, something extraordinary happened. The first stars ignited. Inside the core of a star, hydrogen nuclei fuse into helium. This releases energy, enough to resist gravity, to make the star shine. For millions of years it burns. When the hydrogen runs low, the core contracts, temperature rises, helium fuses into carbon, carbon into oxygen, oxygen into neon, neon into magnesium, silicon into iron. Layer upon layer, the star builds heavier elements. Each step releases less energy. Each step brings it closer to its end. Iron is where the chain breaks. Fusing iron does not release energy. It consumes it. So, when a massive star's core turns to iron, there is nothing left to hold it up. No outward pressure, no resistance. The core collapses. In less than a second, an object the size of Earth compresses to the size of a city. The temperature spikes to billions of degrees. Electrons are crushed into protons, forming neutrons, and the core rebounds violently. The outer layers of the star, still falling inward, slam into this wall of neutrons and rebound outward in a catastrophic explosion. A supernova. For a few weeks, that single dying star shines brighter than an entire galaxy, brighter than 100 billion suns. And in those final moments, in the unimaginable heat and violence of the explosion, elements heavier than iron are born. Gold, silver, uranium, platinum, iodine. Every atom of every heavy element in the universe was forged this way. In the death throes of massive stars, all of it was flung into space. Carbon, oxygen, iron, calcium, phosphorus, scattered across light years, seeding the galaxy with the raw materials for new stars, new planets, new possibilities. For you, you are not separate from this process. The atoms in your body are not metaphorically connected to the stars. They are literally stellar material. The iron in your blood was forged in the core of a massive star that exploded billions of years ago, long before the sun existed. The calcium in your teeth, the oxygen you are breathing right now, all of it cycled through stellar furnaces. We exist because stars died. Every breath you take contains atoms that once drifted through interstellar space for millions of years, atoms that condensed into a cloud, that collapsed under gravity, that formed the sun and the planets orbiting it. Those same atoms passed through billions of years of geology, of chemistry, of evolution, before they became part of you. For a brief moment, cosmically speaking, they are arranged in such a way that they can think, wonder, Ask questions. Where did I come from? And the answer is written in the stars. This is not poetry. This is physics. In 1957, 4 scientists published a paper that would change our understanding of existence. Margaret Burbidge, Jeffrey Burbidge, William Fowler, and Fred Hoyle. The paper became known simply as B-Quad-FH, after the initials of its authors. In it, they mapped out the nuclear reactions that occur inside stars. They showed, element by element, how the entire periodic table is built from hydrogen and helium in the Big Bang, to carbon and oxygen in the cores of red giants, to iron in massive stars on the verge of collapse. I remember reading about Margaret Burbidge's story. Many observatories refused to grant her telescope time simply because she was a woman. She persisted, and her work helped prove something profound, that your atoms have a history older than the Earth. Fred Hoyle worked out the process by which carbon is formed, a process so specific, so finely balanced, that a slight change in the laws of physics would make it impossible. Without carbon, no organic chemistry, no amino acids, no DNA, no life. He called the process nucleosynthesis. We might call it the origin of everything, but the story does not end with supernovae. In 2017, astronomers detected a ripple in spacetime. 2 neutron stars' collapsed stellar cores had spiraled into each other and merged. The collision released more energy in 1 second than the sun will emit in 10 billion years. In that chaos, elements heavier than iron were born. Gold, platinum, rare earth elements, forged not in stellar cores but in the violence of collision. The gold in your ring, if you wear one, was made when 2 dead stars collided billions of years ago. That gold drifted through space, was captured by the cloud that became our solar system, sank into Earth's forming crust, was mined, refined, shaped. Now it sits on your finger. Consider the improbability of your existence. The atoms in your left hand may have come from a different star than the atoms in your right hand. You are a collection of stellar debris, assembled over billions of years, animated for a brief instant by the laws of chemistry and biology, and yet you are not random. The universe has, through stars, through explosions, through gravity and time, created the elements necessary for complexity, for planets, for oceans, for cells, for thought. The periodic table is not arbitrary. It is the result of billions of years of cosmic evolution. Each element has a history, a birthplace, a journey. The oxygen you breathe was made in a star that died before the sun was born. The nitrogen in your DNA was forged in the same process. The calcium in your bones came from a supernova. The iron in your blood, the phosphorus in your cells, the sulfur in your proteins, all of it star stuff. Stars lived and died so that you could exist, not because the universe planned it, not because there is purpose inscribed in the fabric of reality, but because the laws of physics, given enough time and enough space, lead to this, to atoms, to molecules, to worlds, to life, to matter, capable of asking why. To you, standing here, tracing your lineage back to stellar fire, there is something humbling in this realization. We spend so much of our time focused on the immediate, on borders and nations, on the differences we construct between ourselves. We argue over land, over ideology, over resources that will outlast us by billions of years. We forget that we are made of the same substance. Every person you have ever met, every tree you have ever touched, every animal, every bacterium, all of it built from the ashes of stars. There is no fundamental difference between the atoms in your body and the atoms in the body of someone you will never meet living on the other side of the world. You share a lineage that goes back not hundreds of years, not thousands but billions. You are kin, not by culture or choice, but by cosmic ancestry. The iron in your blood, and the iron in the blood of a stranger, came from the same source, a dying star, somewhere, sometime long ago. But we have also learned how to split atoms, how to release the energy that holds nuclei together. We have built weapons capable of returning cities to their constituent elements in seconds. We have altered the chemistry of the atmosphere faster than any geological process. We are capable of unmaking what took billions of years to arrange. This is the contradiction. Matter that can comprehend its own origin can also orchestrate its own end. Your existence required a sequence. Stars formed from primordial clouds. They burned, they died, scattering their contents into space. Those remnants drifted for millions of years, then collapsed into new clouds, one of which became the sun and its planets. One planet formed at a specific distance. It had liquid water. Over billions of years, chemistry crossed into biology, molecules organized, cells formed, life persisted through extinctions, through climate shifts, through impacts. All of this in order led to you. 13.8 billion years of cosmic history, matter arranged into something capable of thought, of wonder, of asking where it came from. This happened. Look up tonight. If the sky is clear, find a place away from the lights. Let your eyes adjust to the darkness, and then look at the Milky Way, that faint band of light stretching across the dome of the sky. You are looking at the place where your atoms were born.
Somewhere in that river of stars, billions of years ago, a massive sun burned through its hydrogen, fused heavier elements in its core, and then collapsed. In the explosion that followed, the calcium that would one day become your bones, the iron that would one day flow through your veins, the carbon that would one day form your cells, all of it was flung into space. You are looking at your ancestry, not your human ancestry, your atomic ancestry, the furnace that forged you. The atoms that make you will not vanish when you die. They will return to the earth, to the water, to the air. The carbon in your cells will become part of other things. The calcium in your bones will dissolve. The iron in your blood will cycle onward. Billions of years from now, when the sun exhausts its fuel and expands, the earth will be consumed. The atoms will scatter. They will drift until gravity pulls them into another cloud. New stars, new elements, new worlds. The cycle does not care whether you understand it. I find it strange that we can know this, that atoms arranged into temporary patterns, into you, into me, can trace their origins back to furnaces that burned billions of years before the earth existed. We are the only arrangement of matter, as far as we know, capable of doing this, of looking back, of asking where we came from. But knowing does not grant immunity. The same laws that built us will disassemble us. The same forces that forged elements in stellar cores will scatter them again. There is no exemption. So when you look up at the night sky, you are not looking at something separate. You are looking at the place your atoms were made. The calcium, the iron, the oxygen, all of it came from there. From explosions, from collisions, from processes indifferent to your existence. You are part of the mechanism, a temporary configuration of elements older than the sun, briefly capable of contemplating their own origin, and then not. The universe does not owe you meaning. It does not owe you permanence. What it has given you is structure. Atoms arranged such that they can think, can wonder, can decode history written in light. The atoms will continue. The cycle will continue. Stars will die. New ones will form. Perhaps this will happen again. Perhaps not. The stars will burn, and the iron in your blood came from one of them.